Good morning, guys.
Good morning.
Morning, Sage. I think your mic might not be working if you tried to talk.
I got to mute in two different places.
Yeah, now you're good.
All right, we had CDM yesterday. Talked about a bunch of usability ops stuff, and RBD caching came up. So we start by going through the pull requests. Not much new. Let's see. There's something about the scrub job priority. I haven't looked at that one yet. Looks like Greg reviewed it. And Mark's tweaking. I haven't seen this yet. Tweaking the throttle cost for hard disks.
Yeah, it's not real interesting.
That looks good though. Let's approve that. And we can just merge it. For the other ones. Let's see, log entry. Oh yeah, those, yeah. The one that I think is proposed fixes that in a simpler way. Can't remember if that merged. The thing that, yeah, it did. That Keeper was going to clean up. So it's fine. So there's a new command for the monitor that will just show you the most recent log entries in the cluster log. And there's a related map of recent entries that's used to prevent duplicates when daemons resubmit their stuff. So that's fine. Let's see, avoiding overlapping extents during reshard. That merged, Igor reviewed that. Dynamic resharding merged. Yay, that's like one of the biggest, most important new things to come to RGW in a long time. Basically, you don't have to worry about bucket sizes in RGW anymore. It's just gonna, when they get big, it's gonna split them. And if they get small again, it's gonna merge them. So one less thing for users and operators to think about. Let's see. I think this omit transaction submission for empty batches. I thought he actually closed this because he had a different approach that he was looking. Yeah, it's closed. Yep, different approach he's looking at. The StatFS thing, merged that this morning. I just forgot to merge it after the rebase happened. Inline memory, that was merged. Yep, and the unshared blobs was merged. Yep, there's a silly bug in that. So that's a pretty good. I don't think there's anything major that's outstanding on the performance front that is super high priority for Luminous. There's the PowerPC Fast Zero thing, which sounds great, but I don't really know anything about PowerPC or how to optimize it, so deferring to to you there.
Sage, did you does that need to be approved?
Yeah, let's see, has anybody reviewed it? When somebody reviews it, can it build? Yeah, I mean, it needs to go through the QA suite just to make sure there's no like build and regressions or whatever. So I tagged it as such. And Peter reviewed but didn't approve. But are you here?
Yes, I'm here.
Yeah.
Can you hear me?
Yep, I can hear you. Yep.
Okay.
Oh, so it's just the.
Yeah, I just commented that I don't have any PowerPC machine in any environment, so I can check it on the live cluster. So I can tell if it actually improves performance or not, or degrades. If it fails, then it's I think fine.
Yeah, if you want, you can add your approved by on there. It just means I'll put the thing in the commit, and you'll get credit, I guess. But yeah, that's fine with me. So I'll run it through QA and make sure it builds. And I assume it does speed things up for you Kestrel's?
Yes, it does.
Yeah, okay. All right. Sounds good. And the other one is this op commit, op applied thing. I think we just need to figure out what path to take there. I don't think this is super critical. It's not going to go into Luminous, I don't think. But yeah, Josh, I think I just asked for your opinion on direction there, but I can't remember what it was. So.
Yeah, I think I didn't take a close enough look at it yet.
Yeah, okay. I think we can wait on that one. That's all right. I think the only other one that's sort of outstanding and interesting is the 12062 PR originally based on Voidbag's work that does all the commits synchronously in case you have NVDIMs or something. I haven't rebased that yet. I think I want to wait until after Luminous to revisit that and wait until we have a little bit more, know a little bit more about what we should be targeting there. Maybe we should get Mark some NVDIMs so he can play with it.
Sure. I'll take it.
No complaints there. Yep, I think all this other stuff is sort of not super important. I can mark some of them DNM, I guess. But yep, that's it from the PR front.
All right. I've got some discussion topics here, but maybe I'll open it up if anyone else wants to speak first. Anyone from the community or anyone else have anything that they want to bring up this week?
Go for it.
All right. So first, BlueStore. So I think I'm going to keep harping on this until we figure out a solution, which means that we might be harping on this for a while. But metadata. That is the big thing right now. So if we don't have cache misses for the O nodes, we can do pretty good. On NVMe, an OSD can do about 38,000 write IOPS, maybe even better, depending on how fast your CPUs are and how fast your NVMe is. But once we hit cache misses for the O nodes and extents and everything else that we've got, it slows down pretty dramatically. I mean, it's on the order of like maybe 10,000 write IOPS instead of 38,000. So it's a big deal. If we can somehow, that's exactly, configure a bigger O node cache. Somewhere in there, I think I even said that, did I? Higher default cache size for SSDs.
Oh yeah, so, there you go. Yeah.
Yep. So I've even got it right there. So yeah, the questions here are, okay, if cache misses are this expensive for us, I mean, yeah, the immediate solution, right, is how big of an O node cache can we make the default for SSDs? And maybe we need a bigger one. But
let's actually just pause right there. So the default cache size that we set for BlueStore is 1 gigabyte, and I sort of picked that because that's sort of similar to what a lot of people, that feels like that should be within the bound of what people have deployed on hardware. But I think technically our recommendations, which should be taken with a grain of salt, were 1 gigabyte per terabyte of disk, which means that if somebody has like a 6 terabyte disk or 4 terabyte disk, then it should be 4 gigabytes per OSD of RAM anyway. So I wonder if we should just set our default at 2 gigs. I don't know. What do you guys think? What should the default?
From my investigations, it took about 1 gig per 128 gig of space, and that's
to
for
keep everything in RAM.
Yeah, and that's for the case when checksums are off.
Okay.
I could keep everything in with 8 gigs for 512 gigabytes. 8 gigabytes of RAM for 512 gigabytes.
Yeah,
I think
so
I was.
that's probably not going to happen. But it's a curve, right? I mean, if we set our cache size at 20 megs, then obviously performance is going to be horrible, and metadata is going to be the problem. So at some point there's just some cost here, and we need to figure out. I mean, it seems like there's two ways to approach it. One is to figure out what sort of a reasonable amount of RAM is that we can expect users with current and future hardware to devote to OSDs, and base it on that. And the other is to try to figure out what the curve is, and figure out where a point close to the knee is on the curve, and then there.
And I can see two other options. The first one is to try to reduce or not as well, and the second one is try to optimize the read performance from RocksDB cache and maybe investigate what's the bottleneck and things like that.
Yeah. If we can, I mean, it'd be worthwhile looking at how much the encoded O-node sizes on average are versus the unencoded, and then also the compressed encoded in RocksDB, how big those are. So from the compressed cache, whether or not we gain anything over just the encoded. Everything is going to be a trade-off, but maybe one or both of those are worth it to save on space.
I think the other one that we should remember is that there's actually a RocksDB cache that is also super arbitrarily sized. I can't remember what it's set at, but it's.
Yes, that's what I mean.
Yeah. Okay. So we should tune that.
Yeah, it might be that's better than the O-node cache on the BlueStore side, right? Maybe keeping most of this encoded is better, or maybe even keeping most of it encoded and compressed is better, which is the RocksDB, because you've got the two caches. You've got the uncompressed and the compressed cache.
You know what? Maybe what we should do actually also is, right now you have like 3 cache settings, multiple cache settings to set.
Yes.
One of them is the BlueStore cache size, which is the memory that BlueStore is managing. One of them is the RocksDB cache size, which is a separate option. And then there's another one that is, I think, embedded in the RocksDB option string, which is super awkward. So maybe what we actually want is to make BlueStore control the RocksDB cache size and configure it as a fraction of the overall BlueStore cache.
Yeah.
And then we in BlueStore we can decide that the best way to spend my memory is 50% RocksDB, 50% me, or whatever it is.
Mm-hmm. Do we have any kind of, do we keep track of how big an encoded a bit of metadata is relative to the in-memory size of it? Do we track that anywhere?
I think so.
I mean, that's one way to start making like live decisions on this, right? Is if you don't get any benefit from, or much benefit by encoding it, you're better off just keeping stuff in the O-node, the BlueStore's O-node cache.
Yeah. Well, so I think it's more complicated than that, because there's the cost of encoding and decoding it, and so even if it's much smaller or whatever, it might still make sense to keep some ratio or whatever. So I think what we really need to do is actually test it. So do some runs where we fix the BlueStore cache size and then vary the RocksDB cache size and figure out, or even better, and then hopefully like what we really want is. And maybe I can do this change first where we configure it in terms of ratio, but like with the specific memory budget, is that memory better spent in the RocksDB cache and just do some A/B tests and to see which does better, and then we can.
It depends entirely on how overloaded your CPUs are, whether or not how much that encoding hurts you there.
Yeah.
Like if you have lots of CPU to burn, then it might be almost free, but if you have like tons of NVMe drives on one node or something, and you're just CPU bound everywhere, then you might want to skip that.
So we'll have to pick just sort of a middle ground there. The open office. Yes. So, but either way, I think simplifying this config seems like a good step.
Yeah.
Well,
yeah.
so back to my original question though. Can we just take a quick poll at the people on this call? What a reasonable amount of memory by default for an OSD process to consume is? Like right now, the BlueStore cache size is 1 gigabyte, which means that the OSD footprint is probably somewhere around 2 gigabytes total with all once you add in all the other stuff. Is that a reasonable default, or should it be 4?
2 gigabytes sounds reasonable for me. Although
Does it
it's a lot.
Does it change if you're thinking about like NVMe or SSD backed OSDs versus like hard drives? Does it make sense to have 2 separate tunables for that?
I think so.
What would you set them at?
This is James. For us, we would like to use more memory to get more performance. So far, on our server, we pretty much have 192 or 128 gig of memory per each server. So we can consume as up to 10 gig per each OSD. Because right now we have a 12 OSD per each server, and we can consume up more than close 10 gig per OSD. But as long as we get a good performance.
Yep. Okay.
Just Sage, I wonder, can we roll some of the other things that we dedicate memory for into this too? Not just the BlueStore cache and the Roxy B cache, but can we get rid of some of the other tunables that we have regarding buffer sizes and other random things, and kind of just give you one number that you assign to the OSD for memory?
The only other main thing that the OSD, there are only a handful of other sort of pools of memory that the OSD uses that are tracked. One is the PG logs, that's the bulk of it. And we do have a mempool of that, so we could base that on memory usage. And the other one is the throttle, the amount of memory we allow to be read off the wire before we process it.
Yeah.
But that's kind of a fixed thing, and it just needs to be big enough to like make sure that we don't starve the OSD of work, but no bigger. So I don't think that's something that is going to be tuned much in practice. I'm not sure about, I can't decide because if you have 10 gigs of RAM, for example, dedicated to your OSD, that doesn't mean that you want to dedicate more memory to logs. Like there's sort of diminishing returns there. So I'm kind of inclined to keep that one separate, but yeah.
Is it something that we ever see a user needing to tweak those values up really high though, like for logs?
No.
I've
never seen them increase it. I've seen them decrease it to reduce memory, but never increase it. So it just means that if your OSD is down, the amount of time it can be down is shorter before it falls into backfill. But it's a rare event, and it's difficult to balance the cost of memory overhead versus time down before you have to do a more expensive recovery operation. It's super difficult to make a judgment anyway. So I'm not too concerned about it.
It feels to me almost like that's one of those things where, if you have little memory, you want to tweak it down, but if you have lots of memory, maybe you very slowly tweak it up. But it's not even a decision the user needs to make, though, right? I mean, if they have less memory, you can do that automatically. You don't need to have them set it to something.
Yeah.
If you dedicate only 1 gigabyte for the OSD to use, then okay, well let's push everything down.
All right. Well, I'll. Let's see. Are you? Let's see. Is Josh? Are you on the call? Do you have thoughts on that? Replacing the BlueStore cache size with an OSD memory, or basing it on OSD memory configurable?
I think in the long term, it would be great to have a single tunable for OSD's memory in general. But think, like you said, there's a bunch of things to getting that into place for that to work.
Before that works well. Yeah. Okay.
And
Yeah, okay, so-
you probably still wanting separate ones for like the PG log stuff that would just be a constant instead of being a percentage of that.
And we don't account for all OSD memory usage either, so it wouldn't work very well.
Yeah, exactly.
But,
Okay.
but maybe that's the
But
goal,
that's
right?
long-term
Is
goal.
to-
Yeah.
Long-term
Yeah.
goal, yeah.
Yeah.
All right, we'll start with the
Hi, Sage,
BlueStore one. Yep.
Yeah, this is Nitin. I just wondering, like, is it possible to like keep track of free memory in the system and accordingly adjust the cache? So that just wondering.
That is a good question. I think it's technically possible, although it's a little bit awkward because there's all kinds of possibility of like feedback loops and noise and whatever. It's not a very precise thing, but you could sort of try. What I'm worried about is that whether that's a good idea. Then I'd be welcome any input or opinions from anybody on that. The kernel can sort of do it because it owns the memory system and it can reclaim any memory it needs to if it needs it for any other purpose. So it just uses all memory for cache by default. But for user-based processes to do that, that's dangerous because the kernel, if they don't react quickly enough, then the kernel will start to swap them out instead of just doing a reclaim. Just sort of a problem. It reminds me, I seem to remember, I don't know, did anybody have any thoughts on that?
By the way, does the BlueStore optimize zero extents in page cache? It's in its own page cache.
The BlueStore has its own cache. It doesn't use the kernel page cache.
Yeah.
I don't know if it optimizes zero extents though. It does not. No, I don't know how common that is, but it doesn't do it. There was a talk of the kernel providing a feedback mechanism so that user space processes can respond to out of memory. But I don't know I don't know if anything like this is usable. That might be a path forward. But even then, you have like if you have 20 OSDs on the same host, they need to cooperate somehow also, so that they only. Yeah, they have to be careful. It would be nice to just have them magically use as much memory as they need and trim as necessary, but there are a lot of things that can go wrong. Like even if they realize there's memory pressure and they try to free bunch memory, if their heap is fragmented, then they won't actually be able to release that memory back to the kernel. So it's, yeah, imperfect situation.
Okay, yeah, I just thought throw an idea. Let's see how feasible is it. So good to know the issues there.
Yeah.
It seems like something that deployment tools could tune when they're installing like XOSDs on a server, look at how much memory it has, and
Yeah.
Conservative portion to each OSD.
You have to be really careful with that, though, if you're talking about like some kind of hyper-converged solution, which seems to be the hot thing.
Sure. In that case, they're trying to constrain memory, so therefore they already have a good idea of how to limit it.
Yeah.
Maybe. I actually don't agree with that. It seems like a lot of times in hyper-converged scenarios, people have no idea how much memory applications they're going to use, like at peak, right? And it ends up. And this is kind of a problem for us now, especially with having static memory settings rather than just using page cache.
So this is a related question, not related to BlueStore, but we currently have this behavior in Ceph where when a PG is degraded, we use more memory. And this is the primary reason why there's this, whatever, I don't know, but this idea out there that Ceph OSDs use more memory when you're doing recovery. It's not because it's hard, it's because we deliberately make the PG log longer so that we can tolerate a longer OSDs being down for longer. So it was written that way as a feature, but it's sort of mostly, I think people interpret it as a bug and something that makes it difficult to do capacity planning. I wonder if we should just stop doing that. Just fix the size of the PG long so that our memory footprint is fixed and doesn't increase or decrease with recovery.
That certainly seems worth testing out, and if necessary, maybe even adding some kind of on-disk versus in-memory semantics, where you keep the longer one on disk as well, but might not even be necessary.
What do we lose in this case? Okay.
It's if the PG log is shorter, then if there's an OSD that's down for, currently if an OSD goes down for like a few minutes while it reboots and comes back up, the PG log will be long enough that we know exactly which objects were updated, and so it can do a very fast recovery. But once you go past the end of the log, then you don't know which objects have been touched, and so you have to do a scan of the data on the OSD in order to resync it and bring it back in. So it just means that that time window where a short down period can be recovered quickly is shorter.
Do we have any kind of knowledge from the field about how often recovery events involve short periods of time like that versus ones where we blow past it anyway?
No.
That's kind of what we need to know, right? If this is even remotely useful, is whether or not anyone actually.
Well, I think there are two questions, like what should the length of the log be in general? And how does that translate to like minutes of downtime? That's sort of question one, which lets you choose what the value should be. And then question two is, should that value be artificially increased or expanded to like doubled or whatever in a degraded scenario to bring those OSDs back in more quickly?
So in terms of downtime, doesn't it kind of depend on the characteristics of your disks and the size of the writes that you're doing?
It depends on what your IO rate is, yeah. That's another sort of weird thing, is that if you have a pretty idle pool, like we're keeping all this memory and your window is very long, or if you have two different pools, the length of the logs are the same, but the recovery window for each is different.
So I don't think we can really answer the question, right? I mean, all we can do is look at, well, we can't even really do this, but all we maybe could do is look at what really happens in practice with people.
Yeah.
But without data, who knows?
Yeah, I mean,
it seems like we're really just.
Go ahead.
I was going to say, it seems like we're really just interested in sort of the IOP and the IOPS that the node performs and how many seconds we want it to last. So I mean, if the default one is 1,000, what is it, 1,000 for PG, and they got 30 PGs at
10,000,
30,000 ops, which for a hard drive is what, 5 minutes? So.
Yeah. I think it's plenty for hard drives, but.
Well, yeah, but I mean, also, like, is that actually enough for a reboot? Maybe we just like double it to 2,000.
I think it's actually 10,000 and not 1,000. So I think we're.
Well, 10,000 is the degraded one. I think 1,000 is the non-degraded one. Or maybe those got turned down.
I'm checking. It's 3,000 and 10,000 are the two thresholds currently. 3,000
so yeah,
times
it seems
30.
like maybe we switch it,
like 15
or make
minutes.
So maybe we make it another rotational media thing and just stick the hard drive one to 3,000.
Well, keep in mind those are also per PG, so we likely have more than one PG per hard drive. Just likely even more time than that.
Well, okay. So here's a question. We could switch. Oh, okay. There are a bunch of questions. One is we could change the PG log trimming so that instead of having a fixed length of log per PG, we have a minimum that we keep just because for like dupe op detection. But then we instead set we do the trimming based on whatever the oldest is across all PGs. So if a mostly idle pool and a very active pool, the very active pool gets a long log and the idle pool gets a short log. So that means that our memory would be efficiently utilized, right?
Mm-hmm.
That would be the first thing.
Idea.
And then the second thing is maybe this should be, instead of configuring the number of entries, we could instead configure the amount of memory, which is now possible because this is actually a mempool. And things like EC pools have much fatter log entries because they have all this other metadata for rollback in there. Or third, maybe we should actually configure this as a time window, or at least report a time window so that you could actually ask the OSD and it'll tell you the current log horizon is 15 minutes or something like that.
Can we within an OSD, can we steal memory from other things now that we have mempools? Can we say, evict all cache, don't do anything else, just give everything to the PG log?
I mean, anything's possible. That would be a lot of work, though.
Yeah, it would be. It would be.
I think
just wondering if it's
that type of thing would make sense once you get into the world where you set the memory budget for the total OSD, and then it has some smarts that figures out how to allocate it. Until we get to that point,
yeah,
I think it makes sense.
Is it even a goal to shoot for, I guess, is what I'm asking.
I'm not sure how useful it is in practice.
Yeah. It feels like, so when a PG isn't degraded, the only purpose of the PG log is for the dupe op detection.
So with the branch that Eric's finishing up now, those should be stored in much smaller amounts of memory.
And in a totally separate structure?
Separate from the PG log entries.
In which case we could make the PG log almost empty in the case where we're not degraded.
Yeah,
right?
yeah.
And reclaim a bunch of memory that way. But it does mean that there's the memory usage will balloon when you have degraded PGs. So I think as long as that makes me think that we should configure the amount of memory that we devote to that in terms of megabytes, so that there's a setting that says that the recovery overhead for logs is 400 megabytes or whatever it is. So then the administrator knows what headroom they have to plan for.
Yeah, I think it would certainly be more understandable.
It's probably more interesting. It might be more like useful to configure, say I actually want a 15-minute window and however much memory that takes, but you can't really plan around that because you don't know how much that's going to be.
So in terms of capacity planning, would a potential customer then say, here's the static value per OSD plus however much per gigabyte of disk per OSD? Is that kind of where we'd go with this?
I don't think it's related to gigabyte of disk. It's actually
no. I'm saying that's part of the static value, right? So we've got like a static value that you have to have per OSD, and then we recommend this in addition per gigabyte disk.
Yeah, right.
And that would be the formula someone you would use for capacity planning.
Yep, and in practice, there's a couple of things that go into that static value. It's the PG log overhead, and then it's also the buffering incoming messages, and so on.
Because of that, I think if we do it like that, we can even get rid of those as tunables, right? If we can just say, this is how much memory to give, this is what you have to have, plus then add this in for your caching to be effective.
Yeah, I like that. So I think we should replace the PG min log max log fields with a amount of memory, where we just say the mempool, PG log mempool gets this much memory.
If we're actually going to go to dynamic stuff like that, I think we probably would rather steal it from the BlueStore cache rather than having it change what the administrator can get allocating.
So that when there's recovery, we reclaim memory from
Yeah, because that way it's a constant value. It's a lot easier. Like, we don't have to talk the administrators into reserving 400 megabytes of free RAM or whatever, because they're never going to get that right.
And actually, the better way to think about that is that when you're not degraded, then BlueStore can borrow the memory, because that's the common case.
Yeah, exactly.
Okay.
Isn't this what I was kind of thinking of, though? Maybe I'm misunderstanding.
Yeah, it is.
Yeah, that's what
exactly
I said that.
But the more I think about it, the more that makes sense.
Yeah, okay.
Okay. Well, let me think about a little bit more how that would implement it. Maybe the way to think about it is that we allocate a budget for PGLog memory, but then have a mechanism to loan it to BlueStore when it's not being used.
Sure.
And that way we're not sort of explicitly. I'm worried about going to tunable for the total amount of memory the OSD uses as like the one tunable, because I'm not sure we're accounting for enough of our memory usage to like actually respect it. At least not yet.
Do we have the pieces in place that we can do it? I mean, is there stuff out there that we're really worried about that we can't account for easily?
I think we need to evaluate that experimentally by just looking at production clusters and comparing the mempool with the actual RSS and figuring out how well we're doing.
And a big part of it is like tcmalloc, right? And like thread cache and other things that are hard for us to account for.
There's thread cache and there's just heap overhead. Like even if we account for everything, there's like, we're going to pay like 20, 30, whatever, how many percent, just because it fragments. That happens over time. It's dependent on access patterns. It's like super hard to account for.
Yeah.
I feel reasonably good about the BlueStore cache accounting, because I've run an OSD under load with a configured cache size and seen the RSS stay at a fixed size. But there's a delta between the actual RSS and what the BlueStore cache size was. And I'm not sure that everything else in between there is sort of accounted for well. But. Okay, well anyway, that gives me a couple things. So one is the BlueStore RocksDB cache ratio, one is the borrow memory from PGLog and configure log in terms of RAM. Does that seem like a reasonable approach to you guys? Josh and Greg?
Yes.
Yeah, I think in general it sounds like a reasonable approach. I think as long as it's not too complex, it seems like something that we could do pretty easily.
Okay. Cool. Okay.
And Sage, I can at the same time try to see if I can look at how RocksDB's both compressed cache and uncompressed cache and the O-node cache all kind of battle with each other or not. Work with each other, we'll say, to do this. All right. So buried in all this, I've got this little LMD proposal that I discussed at CDM yesterday, but I don't have to go over it. Just if anyone is interested, I'm trying to resurrect Shinchin's old PR for LMDB and see if I can make it work and maybe give it another try. I never really got the impression that we did a real evaluation of why it was slow for writes and kind of see how bad it really is. It may be that it's totally worthless, but we'll see. The only other thing I've got on here was the Writeback throttle settings. That this has come up again. I figured we should probably hash it out a little bit. I hate this discussion because I feel like it's just a giant spectrum of ick, where yes, we can make it We can make it, have more sinks that are shorter, or we can have fewer sinks that are longer. And there are advantages and disadvantages to both, and we go back and forth on the spectrum of, well, maybe it's better to do this, or maybe it's better to do that, and it always just kind of sucks. That's kind of the conclusion I've come to.
Yeah. Yeah. I think it kind of doesn't matter so much where we end up here, because you're sort of on the spectrum between batch throughput versus like, tail latencies and burstiness or whatever, having more consistent performance. So it's not like there's a wrong answer.
Yeah.
But these numbers just feel huge for a hard disk. Like the hard limit of 5,000 seems huge.
Yeah.
Like it seems like an order of magnitude off.
I
think but for hard disks it does.
Every time that we revisited making those smaller, it seems like what happens is we test it out and it's slower, and then we back off because we're like, okay, it slows us down. Maybe there's something unreasonable that we're doing that's the reason why it slows us down. But then we are like, okay, we can't take the 10% performance hit or whatever. It's not, it's too big. People are going to be pissed, and then we don't. So, and when we can, it's just every time we've tried to do this in the past, it seems like it gives us a performance hit that we're not willing to take, or that product's not willing to take.
Yep.
So
yeah, I don't know. I mean, I kind of lean towards whatever like generates the least support from users and customers. I don't know.
Do we, with the current values, even though that they're what we see is ridiculously high, do people run into issues with the OSDs dying because the syncs are taking too long? Is that actually a real problem that people run into?
I don't know.
It hasn't been something I've heard people complaining about, but I could be wrong. I don't have a whole lot of insight into customer problems these days.
Josh, do you have a sense of what customer issues you've heard? Or Greg?
I'm not sure. I've seen this.
I don't have numbers, but it definitely happens. It's conceivable that we've added enough other throttles since the last time that it's no longer an issue, but certainly a couple of years ago it happened pretty frequently, and I think it still happens periodically.
If we could even just get, if those happen, if someone could flag them so that we can actually get a sense of what it is, I'd feel a lot better about justifying the performance hit to the people that yell at me whenever we see, performance problems. That would,
maybe we can ask,
make it more.
Get to what he's seen recently, since he sees all of these cases, or most of them.
That sounds like a reasonable way to gather some data.
I mean, so when you were doing this testing, did you actually run it on hard drives and turning it down from 5,000 slowed you down, or was it just an SSD thing?
There's, yes, both, and several times over the last 6 years. I mean, it comes up maybe every year or two that, let's look at the writeback throttle settings again, and it for whatever reason, the setting them really, really high seems to be the thing that helps. It's not just kind of high, but kind of having no, setting them so high that it's not even effective, right?
Yes, when they're not effective, then you just sort of pile write IOs in. As long as your benchmarking test is short enough that all gets swept up, then you're great.
Well, it's what, a 5-second window that you sync on?
No, it's much longer than that.
Is it?
Because it's the XFS delayed writeback stuff when it has to push stuff out of its on-disk journal and into the actual directory structures and things.
That's 30 seconds, isn't it?
from its on-disk journal into its directories, I have no idea. I think it's when the journal gets full, but
I think I thought for some reason there was a 30-second limit on that, but I might be wrong.
that sounds like a dirty memory thing to me.
Maybe.
Not a dirty disk.
I guess what comes back to for me then is okay, is it actually is what we have now causing problems in practice? Because we could spend a lot of time on this for file store, right? I mean,
yeah, I don't want to spend a lot of time benchmarking.
Can't we just like split it into SSD and hard drive ones and set the hard drive ones where we think it should be by running some napkin math? Like if that causes problems, then people will tell us.
How do you want to set the hard disk ones?
By doing math and saying, okay, it does 100 IOPS.
Got it. Yeah. Okay. Yeah, I think we can do that. So I pinged BCAT. Let's just hear what he says, so we get some sense of the pain. But I think even if we don't make a dramatic change there, we might as well just do the work and split them out, and we can adjust. That'll let us easily adjust up and down going forward.
I mean, arguably too, we have more leeway with file store now that if we're pushing BlueStore as the future and saying, go use this. We could just adjust file store down and be like, if it's slower, deal with it.
Yeah, there's still every deployed cluster out there isn't going to use it for a while, and conservative users won't use it for a while. So we still have to. We can't totally not care.
Well, but I mean, we could make file store more conservative now since we have BlueStore there. That's what I'm saying is that we could just make it slower and be like, file store slow. That's just the way it is. It's slow. Don't look behind the curtain. It's slow, and it's safe.
That's true. All right.
I'm not even sure if it's worth paging. Let's see from BigCat. Let's see whether it's actually causing any issues right now or recently.
Yeah, I guess it's slow argument cuts both ways, right?
Yeah, exactly.
Yeah, let's see what he says. All right. Anything else people want to talk about?
Hey, Sage, this is Mohammed.
Hey.
I have a couple of questions. The first one is related to that BlueStore issue that we were talking about. I was wondering, how does it compare to FileStore? So is it still an improvement over FileStore, or does it degrade past FileStore?
Which issue?
The one related to RocksDB cache, when the amount of metadata becomes quite large.
My understanding is that we're still consistently better than FileStore for hard disks and sort of normal SSDs. When you start using fast NVMEs, then we're pretty close. I think the last time I saw a number where BlueStore was actually slightly slower. The main problem there is just that the NVMe is no longer the slow thing. It's not the bottleneck at all. Their bottlenecks are elsewhere in the stack, and BlueStore is doing a little bit more work than
right.
FileStore and XFS, but I'm not sure where we land now.
So adding on to that, from what I've seen recently, when O nodes are in cache, BlueStore is pretty significantly faster now for like random writes. Since we did the KB sync thread splitting, that was a big benefit. But when you're out of cache, like if you're significantly out of cache, then we're probably slower.
Okay. So I think it feels to me like the takeaway here is that if you're going to get performance out of NVMEs, you need to make sure you devote plenty of RAM
cache. Yep.
To your cache, yeah. Yep.
Got it. Thank you.
Yeah.
The other question that I have is that I benchmarked the buffer list at a very fine-grained level, I have some interesting results. I'm going to send them out soon. I'm not going to do it right now just because I haven't completed the benchmarks. What is missing is that I want to change the SCD list to an SCD vector.
Yes.
And just see what. So it's not as straightforward. Like it's not just changing the declaration in the code. So I was wondering if someone has already code for that, so I can reuse.
No.
Otherwise, I'll do it. But
We've talked about it several times in the past and looked at it. I think actually the last time we talked about this, the proposal wasn't to switch to a vector per se, but to switch to Alan Samuels a while back did versions of the SDL containers that had a custom allocator that was statically in line with the declaration. So there'd be like with the list declaration, there's an inline buffer of like 5 entries or something. So if it was a short list, it would be stored inline, and if it was long, then it would fall back to a traditional list. I think that was the proposal we talked about before. But it might just be that with a straight up vector, it's simple and easy. That would also work too. But it would be nice to, the nice thing about the container list type was that it was, his container types was that they were drop-in replacements for the STL one. So they would still support things like swap and splice and everything. And they would fall back to order N if they were inline, but N was always like 3, so it didn't really matter. Does that make sense?
absolutely. Thanks a lot.
Okay. There's still a pull request that's DNM with his original prototype for those types. It needs love before it can sort of be resurrected. But I'm still hopeful. I still think that that's probably a good path forward, because once we have those types in place, we could sprinkle them all over the code base in places where we expect the containers to be small and avoid any allocation. Because everywhere we're doing like sets of OSDs in the OSD, all those short lists could just avoid an allocation completely, because they're always less than 10. But so all that said, I'm very interested in hearing what your benchmark showed, because that'll tell us what direction to go in, I think.
Great.
Now it's this plus shirt.
Anybody else? All right. Thanks, everyone.
All right.
Have a good Thursday.
You too, Sage.
See you guys.